Good evening, everyone. In this session, let us learn searching and sorting techniques. Why you need to search or sort. What is the necessary for searching and sorting? For suppose I am having 1,000 students in my class. Now I need to find out the particular student has awarded marks or not. So for this scenarios, in the scenarios, I need to search the element, right? And if is sorting, in some cases, I need to sort the elements according to their ascending order or descending order. When the students' roll numbers are in an uneven order, so I need to sort them in the given order, specified order. So in these scenarios, I'll just use sorting techniques. So operating on data, all we do is a storage of data or either operate the stored data. So for those things, for finding a particular element, we need to search the arrays, we need to search in between the data, and for the given data, we need to sort either in the ascending or descending scenario, right? Now I'll just let you the different searching techniques: linear search, binary search. So let us now see linear search, right? Let us go with the linear search now. And here I'll just discuss if I am having array of elements. Let us take the elements 20, 12, 45, some 789, some elements randomly in an array. So I have taken the elements in an array, right? So here the what is the index? It is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So the total size is n minus 1, that is 9, right? Now I have to search at which place my 789 is located. Now I need to search the element 789. Now what we will do, as we have the array, initially in my program I have to read the array, right? So for reading the array, as we know, we will be declaring an integer I starting from 0, I less than or equals to n, or else I less than n plus plus I, right? So I'll be reading the array. So scanf, I'll just direct scanf, I will be reading percentile t ampersand a of I, right? So this is how we will read elements of the array, right? Now after reading, we have to search a particular element. So we are taking a variable search, search variable, right? In this variable, let us take the element to be searched. Okay, the number, what is the data to search, we will take in the search. So my search element is some 789. Okay, so I'm taking search, right? So here I'm searching this element. Now I have to, how I will search? First, initially at 0 I will search, that means a of 0 double equals to search. Is it equal? No. Then I'll go to the next location, a of 1. Is it equal? No. Likewise, I will go on incrementing the array, right? Incrementing the array until I found the element. If it founds at 4, that means a of I double equals to search element, then I'll print the element is at the location, at specific location. I'll print percentile T, the element at some A of I. I'll print at the location, at which location it was present, right? So now, for suppose now this is not the element for us to sort. Let us see if this is the element to search, right? So until first initially we will start with a of 0. No, a of 0, the value at a of 0 is not equals to the search element. And again, the value at a of 1 is not equals to the search element. The value at a of 2 not equal, a of 3 not equal, a of 4 not equal, a of 5 not equal, until we find the element in the last location. We are searching, searching, searching. So, can you say me what will be the drawback of this? If my size is, array size is some 1000, right? If my array is of 1000 or 10,000 records, my element is at the last location. Yes, if it is at the first location, it is simpler, right? So we can save the time and execution speed, all those things. Now if the element is at the last location, what is the drawback? It has to search all the locations, and until it finds, if it is in the last, it has to search. Even though it is in the last, we have to go through all the locations to find the element. So this is the drawback of linear search. Okay, so to overcome this drawback, we will be going to the binary search method. Okay, so this is the, like I can say, this is the code. Simply I can say, if the search element is double equals to a of I, printf found at the specific location a of I. Done. Now I'm just going with the binary search. So in the binary search, I'll just take another table. Okay, so here in the binary search, let me take the elements some 10, 20, 30, 40, 50, 60, 70, 80, 90, and some 100 I will take. Okay, so in the binary search, I am taking the elements. Now, like suppose before that, suppose the same scenario I'm explaining, I'm having some 10,000 elements. Okay, so the element I need to search is at the location some, let to make simplifier, let us take 1,000 elements. Okay, 1,000 records are there for me. I need to search the element at the place 999. As of now, let us take like this, right? So at the location 999 means 990. If you go with the linear search, it has to search 998 elements, and at the 999 element, it is finding the element and it is printing, right? Now if I divide the uh, table, or else if I divide the array into two parts, right? If I divide the array into two parts, and if the element is in the if the search element is greater than the element in the list, so you can go with the right side. If the element is lesser than, you just check the left side again. So the one and only must and should mandatory condition in binary search is all the elements are must be in the sorted order. If and only if the elements in the sort are in the sorted order, we can go with the binary search, right? So now here my elements are in the sorted order. Just simply you can say your roll numbers. Obviously your roll numbers will be one after another, some 1 2 3 4, likewise it will be. So if and only if the elements are in the sorted order, we can perform the operation of binary search. Now the element I have to search here is, let us assume 90. Okay, the element I have to search is 90. So I can take uh, search equals to 90. The element to be searched is 90. So now I have to divide the table. I have to divide the array. I have to divide the list so that the left half it will be remaining with the lesser elements than the search, and the right half it will be greater elements. Now I'll just give the values here. I'll just assign for a of 0. I will be assigning low, the variable low, and for a of n minus 1 I will be giving high value. And so if a of 0 equals to low and a of like n minus 1 is high, then mid equals to low plus high divided by 2, right? So now what will be your mid element? It is low 0 plus 9 divided by 2. Somewhere approximately we will be giving some 5 or 6. Okay. So here this will be the mid value. Now if m equals to m greater than search element, mid value if it is greater than search element, you will be assigning your mid value to m equals to, it will be becoming high, and the low remains the same, and the mid value again changes here, right? If it is the search element is lesser, means you will be considering the right half of the list. Okay, you will be considering the right half of the list, right? So now your mid element will becomes a lower element, and your higher element will remains the same, and the again the mid element changes. Okay, again you will repeat the process. You will ignore this part of the array. Okay, because obviously we are not able to, we will not find out the element here, so we will be considering this part of the list. Now again we will repeat. If the element to be searched is lesser than, if it is equal means it will return. If it is equals to the mid element means it will return the array. If it is not, if it is greater means again your mid will become, we will be assigning mid to low, and you will refine high as well, and your mid value changes. Now here my mid is equals to the search element. So I will be returning the element to be searched, right? Let us now see what are the different sorting techniques. So it is bubble sort, and another one is merge sort, and the third one is insertion sort. We will be seeing these three sorting techniques in the next session. Thank you all.